to all at home. Thank you for watching iTTV. Do you still remember, students, what we learned in our previous lesson? It was all about physical quantities and their units. There was so much of numbers, weren't they? So today we begin our new lesson. What is it? It is the concept of mass and measuring tools. So let's begin our lesson with what is weight actually. So what do you think is the gravity pull which pulls all objects in this world to the center of the earth? It is known as the force of gravity or gravitational force. So let's begin today's lesson with seeing what is the proper definition of weight. The weight of an object is the pull of the earth on this object, or in other words, the gravitational force acting on the object. So when you remember weight, students, remember it's actually the gravitational force acting on the weight or the certain object. So let's see further of all the features of weight. The weight can change. Now what do they actually mean here that the weight can actually change? In different parts of the world, the gravity pull actually differs. Now let's take the poles and the equator for an example. The poles are actually situated in the north part and the south part. So compared to the equator, the poles have got greater gravity force. So your weight would actually be much higher when you're in the poles compared to the equator. Now let's take the mountains and the sea for instance. Now on top of the mountain, the weight is actually less because the gravity pull is less compared to under the sea. Now this is how the weight actually differs. Let's see the next point regarding weight. So the weight of the object differs from place to place. As I told you before, the weight of an object is less if it is further from the center of the earth. So always remember that it is lesser at the equator and lesser on top of the mountain because they are both furthest from the center of the earth. The SI unit for weight is Newton. So remember that when you actually weigh someone's weight, you're actually weighing them in Newton, N-E-W-T-O-N, Newton. What is actually a spring balance? The weight is measured by a spring balance or compression balance. Now we'll see compression balance later. This is an example showing you spring balance. So why do they actually call it spring balance? This is because in the balance, which is this object which weighs weight, we have got spring. This is an example of the compression balance. So this is another way you can weigh weight. So remember two different types of balance. Firstly, spring balance. Next, compression balance. Now, I'm sure you would have seen this compression balance when you go shopping with your mother or father. This is because this compression balance is actually used to weigh things like rice and flour. Mass of an object is the amount of matter in that object. The mass of an object is constant at any place. So when you remember weight, what you remember, students, it's gravitational force acting on certain object. So when you remember mass, what do you actually recall? You must remember that is the amount of matter in the object. Two different words for weight and for mass. Weight is gravitational force, while mass is actually amount of matter. Now here they told you that the mass is actually constant everywhere you go. So what do they actually mean? If you stand on the equator or you're at the poles or on top of a mountain or below the sea, the mass doesn't change. It is actually constant. But weight always changes according to the place because it depends on the gravitational pull. Let's see the next point. The SI unit for mass is kilogram, kg. So do you still remember what is the SI unit for weight? It was Newton with a capital N. So when you remember weight, remember Newton. But when you remember mass, which is always constant everywhere, remember kilogram, which is kg. The mass of an object is measured by using a lever balance or a beam balance or an electronic balance. So these are actually the balances used while you measure mass. When you remember mass, remember lever, beam, and lastly electronic. Do you still remember what we used to measure weight? It was spring and compression balance. So to weigh how much in Newton and to weigh how much in kilograms, you have to use balance. Balance is actually the tool used for weighing mass and weight. This is an example showing you beam balance. Next is an example showing you electronic balance. So what is the main point that you should remember when you recall weight and mass? Let's see how do we actually connect kilogram and newton. How do you actually change 1 kilogram to how many newtons? The point to remember is 1 kilogram is equivalent to 10 newton. So an object which is 1 kilogram in mass weighs 10 newton. So just imagine you're 40 kilograms in mass. So your weight is actually 400 newton. 40 times by 10. So this is the point that you should remember when you remember kilogram and newton and their conversion. So let's see further what are the main differences between weight and mass. Firstly, mass remains the same at all places, but weight changes according to the place. So I hope you can remember regarding the mountain, sea, equator and the poles. The amount of matter in an object, the pull of gravitational force on the object. So this is actually the definition of mass and weight. As I told you earlier, when you remember mass, remember matter. When you remember weight, remember gravitational force. SI unit is kilogram for mass, but for weight, SI unit is newton. Lastly, let's have a look at the tools that you use to measure weight and mass. So, we have got beam balance, lever balance and electronic balance for weighing mass. But for weighing weight, we only have spring balance and compression balance. Now, you just have to remember the first few words of each. Like for mass, you remember beam, and you remember lever, and you remember electronic. But for weight, you remember spring, and lastly, compression. The other last ending word is the same, it's balance. So these are the main differences between weight and mass. I'm sure you can remember them, students. So let's move over to the Do You Know segment to learn a few interesting things about the concept of mass. Did you know that there is no gravity in space? So tell me, students, what happens if there is no gravity? What would happen to you if there was no gravity on Earth? Would you be walking or would you be floating? Let's have a look. This is why astronauts float around in their spaceships. Now, because there is no gravity or no gravitational force in space, what actually happens? There is no pull for these spacemen who are out of space so that they can actually walk in their spaceships. So this is the reason why they are floating away in their spaceships. There is no gravity, no pull. So there is no ability to actually walk on the ground. So let's see further about another thing I prepared for you in the Do You Know segment. What about the gravity on the moon? The gravity on the moon is much weaker than the gravity that we have here on Earth. This is why moonwalking for astronaut is very difficult. So, can you tell me who was the first person who ever landed on the moon? It was Neil Armstrong. He was an astronaut. So, in the moon, the gravity is actually much lesser compared to Earth. This is why they say moonwalking is difficult. So you have learned that in the space, in outer space, you actually do not have gravity. But on the moon, the gravity is much lesser compared to Earth. Remember all of these points. So we have actually reached the next segment of the day. It is about measuring tools. So what kind of measuring tools do you actually know? Let's see the first one and let's learn about rulers and measuring tape in the topic of length. So how do you actually measure a length of an object? This is point A and this is point B. So what is actually the distance between point A and point B? Is this actually length? Let's have a look at the next object. This is point A and this is point B. So how do you define length actually? Let's have a look at the graphic, students. Length is the distance between 2 points. The SI unit for length is meter. So remember, students, that length is actually the distance between 2 points. Earlier, I showed you the pencil. A and B is actually the distance between 2 points. So, the length of the pencil would actually be the length of A to B or B to A. So, this is actually how you define length. The SI unit for length is meter. Do you still remember the SI unit for weight and mass? For weight, it was Newton, and for mass, it was what? Kilograms. So, now we're talking about length, it is meter. Shorter lengths are measured by using centimeters, which is cm, and millimeters, mm. Long distance are measured in kilometers. So, your books, pencils, pens, or anything small like your bag or so on, you would actually use a ruler to measure them. But the distance from maybe Kuala Lumpur to Ipoh, you have to say them in kilometers. So this is actually how you use centimeter, millimeter and kilometer to compare length between the distance, which is A and B. 1 centimeter is equivalent to 10 millimeter. 1 meter is equivalent to 100 centimeter. 1 kilometer is equivalent to 1000 meter. So this is actually how you convert from centimeter to millimeter, from millimeter to centimeter, or from meter to kilometer. These are the equations, so remember them, students. So how do you actually measure a straight line or a curved line? Firstly, let's have a look at the objects that you use to measure a straight line. Measuring straight line, we use the meter ruler. It gives the accuracy of 0.1 centimeter. A ruler can be used to measure the short straight line or objects. So let's have a look at the example of the meter ruler. Here we have meter rulers. They come in the shapes of long rulers. So the first one is the wooden ruler. The following ones are the plastic ruler. The correct reading can be obtained only if the eyes are vertically above the mark on the ruler. Parallax error occurs if the position is wrong. So in the diagram in the PowerPoint, you could see that the position of the right eye position and the wrong eye position. So make sure when you measure using a meter ruler and an object, you see correctly. Do not see from any sides, but look right above to see the correct way of measuring the length of an object. A measuring tape can be used to measure long straight line. Now, if an object is too long to be used by the ruler to measure something, you can measure the length using the measuring tape. This is an example of the measuring tape. Measuring curved lines, we need a thread and a meter ruler. We actually need a thread and a ruler. These two objects can be used to measure curved line. Oppisometer. The length of a curved line can also be measured with oppisometer and a ruler. So remember that a curved line, we can use thread and ruler or oppisometer and ruler to know the length of a curved line. What about the diameter of an object? Measuring diameter. Internal calipers used to measure internal diameter. External calipers used to measure external diameter. So, when you remember about diameter, always recall that we use calipers. We have got two different types of calipers. Now, the ones I have here are actually the external calipers. We also have internal calipers. They are all used to measure diameters. Let's have a look at the chart or picture here which I have prepared for you to see further in detail regarding the calipers. Now firstly, let's have a look at the external caliper. The external caliper can measure the external diameter of the beaker. It measures external diameter. What measures the internal diameter? The internal caliper, obviously. See how they are put into the beaker to know the diameter of this beaker. So now you have an idea of how do you actually use the external and internal calipers. So what have we learned so far? How to measure straight line, how to measure curved line, and how to measure the diameter. So let's see further about the exam lab to see a few spotted questions for the day in this lesson today. Question 1. What is the function of the caliper? A. To measure straight line. B. To measure volume. C. To measure diameter. D. To measure temperature. Now, to measure temperature, what do we actually use? The thermometer, obviously. So, to measure straight line, we use what? The meter ruler or measuring tape. So, what is the correct answer here? Is it to measure volume or to measure diameter? We have got two different types of calipers. Firstly, the external and the internal. Let's have a look at the correct answer. The correct answer is C, to measure diameter. The internal calipers we use to measure the internal diameter. The external calipers we use to measure the external diameter. Let's see question 2. Question 2. Following are the units for length except A. Newton, B. Kilometer, C. Meter, and D. Centimeter. So what is length actually? Let's recall the correct definition of length. It is actually the distance between 2 points A and B. So this is actually length. So what is here not the correct unit for measuring length? Let's see. The correct answer is A. Newton. Therefore, students, do you still remember what is the unit Newton used for? Yes, you're right, to measure what is the weight, Newton, N, the capital N. So, this is the correct answer for question number 2. Kilometer, meter and centimeter is used as a unit for measuring length. Let's see question 3. Question 3. Which of the following is not true about mass? A. Mass is constant. B. Mass is the amount of matter in an object. C. SI unit for mass is kilogram. D. We measure mass by using spring balance. Would you agree with me if I say that mass is constant everywhere? That is because mass is actually the amount of matter in an object. So automatically the answer option B is also correct. So you have to decide, students, whether C or D, which is the correct answer. So let's see. The correct answer is D. We measure mass by using spring balance. But that is not true about mass. What do we use spring balance for? To actually measure weight of an object, not the mass. To measure mass, we actually use 3 different kinds of balance. Firstly, the lever balance. Secondly, the electronic balance. And thirdly, what is the last one? I'm sure you could remember. So this is the exam lab for the day. Let's do a quick roundup of today's lesson and see what have you actually learned so far. The weight of an object is the pull of the earth on this object, or in other words, the gravitational force acting on the object. The SI unit for weight is Newton. The weight is measured by a spring balance or compression balance. When you remember weight, remember these few words: spring balance, compression balance, the unit Newton, and gravitational pull. So you would have covered everything about today's lesson regarding weight by remembering these few points. Mass of an object is the amount of matter in that object. The mass of an object is constant at any place. The SI unit for mass is kilogram kg. The mass of an object is measured by using lever balance or beam balance or an electronic balance. So when you remember mass, the point you have to remember is amount of matter in an object. We use kilogram or kg, and we use what? Beam balance, lever balance, and lastly electronic balance to measure mass. Length is the distance between 2 points. The SI unit for length is meter. Shorter lengths are measured by using centimeters cm and millimeters mm. Long distance are measured in kilometers km. So always remember that length is the distance between 2 points. So this is basically the summary for the lesson today. That is all for today, students. We have actually reached the end of the lesson, but we are not done yet about measuring tools. So in the next lesson, I would see you with a topic of measuring tools. Till then, take care and have fun learning.